inspirational information. So there we go. It's on the right microphone. Everything looks pretty good. Okay, so I should have it. Right, here we go. So this is John McAfee. If you don't know John McAfee, count your blessings. But anyway, see if I can make the sound bigger. Right, what's going on here? How about this thing? There we go. Okay. Oh, looks like there's a problem with my sound device. There we go.
It was created because this world is fragmented.
There you go. Okay.
Since I started my campaign, I get lots of questions. What would I do if? What would I do to prevent war and start peace? What is war? How is it created? It is created because this world is fragmented in understanding and knowledge. We have 1,000 different perspectives of reality. Yours with your religion, your culture, your government, your history, and theirs with theirs. In few places does this reality intersect. Would you fight for your reality? Of course you would. It's all you have. It's all you have. I can't stop it. But what if there were a revolution of the mind where all of these disparate understandings became one? One. The truth, of course. It's all my truth, your truth, and their truth is the truth, as seen by all and understood by all. How do we do that, you say? Through the blockchain, that immutable record of reality.
There you go.
Implemented properly.
So the answer to everything is the blockchain. It's going to save the world and end war. It's the answer to everything. So that's why we all got to be here and learn cryptography, because the blockchain will save everything. By the way, blockchain is the new religion. The proponents actually believe all this nonsense that it's going to save everything. And anyway, John McAfee, and that's what he does for money now. He said like 3 years ago, he said, I will promote any cryptocurrency product and tell people to buy it. And he's been telling people, oh, don't worry, Bitcoin will just keep going up. Oh, don't worry about the crash, everything's fine. Buy, hold, and he gets paid to say that. And he boldly says, I'll say it to anybody, just pay me money and I'll promote your product. It's kind of like Donald Trump. Everybody knows he's lying and it doesn't seem to matter. A whole bunch of people love him anyway. So anyway, I think Paper Ghost is right. He said if John McAfee didn't exist, we would have to invent it. He's like the wild man of security. He's fulfilling the ecological niche vacated when Hunter Thompson died. So anyway, all right. So so now we're pretty much up to the right time. So this is 141, cryptography. And so I'm going to talk about the grading and such. There is a handout on paper if you want it, telling you how the grading works, but it's all on my website. I'm not that much into paper, but you can get it on paper if you like. I have a new textbook this semester, A Serious Cryptography. This is a very good book. This is an optional free book about the cryptocurrency. The main focus of this class is learning how to use cryptography correctly, but I have a lot of cryptocurrency projects and blockchain projects because that is a very important application of cryptography these days. And so you can do those. There are a ridiculous number of projects, and I'm still writing more, so you can actually tune your class to meet your objectives. There are ones here that cover the normal kind of cryptography, like AES and RSA for the serious mathematical types, and there's a lot of Bitcoin and cryptocurrency projects too, if you want to focus on that, which a lot of people do, because there is a huge amount of interest in cryptocurrencies and blockchains and the related products. And I'm beginning to hate it less. I used to be absolutely opposed to this stuff entirely. I'm beginning to see some value in it, although about 1% of what people like John McAfee think. I do not think it's going to end war and save the world. It is just another form of database, which will have some value. Anyway, so let me just mention how the grading works, which is pretty simple, the way all my classes work. You do not have to attend class. You don't get points for attending. You don't lose points not for attending. All your grades come from quizzes and projects and the final. The quizzes are all online in a Canvas system. Last semester, people had to get an email and be invited to join. I figured out how to turn that off. So now you can join just by clicking this link here. And that will enroll you in the class. And if you have taken one of my classes in the last year, you already have an account on this server. You just have to log into your account and join the class. If you haven't, you'll have to create an account. This is not the City College Canvas server. I use the API, and the City College administrator allows me to use this server, so I use a different server. So if you contact the City College help desk, they can't help you get an account on this. But you don't need anybody's help. You just click that link and join. Anyway, that's where the quizzes are. You'll see quizzes there. If you want to take quizzes, and your grade will appear. That's all I'm using for. And I you figured out how to turn it. All right, and let's see what's happening here. I see a chat coming in. Don't forget to mute. Thank you. Thank you for reminding me. The participants in Zoom, I need to mute them or they will hear each other's dog barking and stuff. Good. All right, so thank you. Anyway, so I'm live streaming this. You can watch this lecture live anywhere by clicking this Zoom link. And after class, I put it on YouTube. You can watch a video. You can also ignore both of those things and just read the textbook if you like. All I care about is that you learn it. If my lecture is helpful, that's fine. If it's not, learn it some other way. And your grade just comes from homework and quizzes. And the homework comes in by email. And the quizzes are done on Canvas. And so you get 90% an A and 80% a B and so on. If people actually commit cyber crimes or something, then I can kick them out of the class and give them an F, and that will be the least of your problems. But anyway, I put this here in case that happens because I do occasionally get people that are doing bad things. Not too often, but I have to have that there. Anyway, and I've got plenty of ad codes if anybody needs them, but as you probably discovered, they won't do you much good because the City College ad system is not working. But you can take the ad code, and they said they're going to extend it for another week. What happened is the chancellor was told towards the end of last year, the system you're using is going to reach its end of support in December of 2018. And somehow a vendor convinced him that means we have to quit using it right away, which, you know, just because it's no longer supported doesn't mean you have to panic and stop using it right away. But that's what happened. So they tried, and he believed some vendor telling him, oh, it'll only take a month to move over. And, you know, if you've done some IT project management, you know it's never like that. Because the product they made might move in a month, but of course you have written 100 other things ad hoc that the vendor doesn't know about that rely upon the old system that won't move over. So anyway, that's why currently the system is sort of up and down and crashed and messed up. Anyway, all right. Anybody got any questions about the administrative stuff? Yeah.
So there's just no way to add, give the code until they fix it.
Some people have told me they did succeed in adding by just being very patient. It's just very slow. The official City College website says just wait about a week, I think.
You actually can do it manually. I just went there.
Oh, you can just go by hand and do it. Yeah, that's right. You can fill out a form and do it manually. That's another way. Do it on paper. Yeah. So I mean, you can do it. Anyway, if you don't have an ad code, I can give them to you later. But I think anything else? Yeah.
It looks like the link that you provided for mastering Bitcoin doesn't really go through directly.
Oh, okay.
It goes to the O'Reilly's.
Oh, okay.
Page, but there's somebody's.
It is. There's a free version of it someplace.
Yeah, somebody's S3 book has it.
Yeah, let's see. Oh, you're right. Well, there used to be a free copy of the book. Thanks. I'll check and see if I can find another link. That book is around for free, but I'll have to update to a different link. Thanks for telling me. Okay, good. Anything else? All right, let me just talk a bit about Bitcoin, and then I'm just going to start doing some of the math. There's not very much math in this course, by the way. All we're going to do is a little bit of basic algebra and a little bit of Python. You don't need to know much math to do it because I'm not trying to turn you into cryptographers that could invent a new cryptographic system. I just want you to learn how to use the existing systems correctly, just like engineers. That's all. That's all normal people should do, is just use cryptography the way it is. Writing cryptography is something that just a small number of geniuses should do, and the rest of us should just slavishly use it. Because if you think you're smart enough to write a cryptography system, then you're stupider than you think you are. Unless you are one of the 10 smartest people on Earth, beyond a PhD in mathematics, you are not smart enough to write your own cryptography system. And if you try, you will create a disaster. Many companies do this. They make up their own crypto, and of course, it's garbage and they get hacked. Yeah.
Can I ask you a quick question?
Yeah.
What do you think about quantum?
we're gonna do some quantum calculations here, and you'll see quantum computing is coming. And when it comes, it's going to change the cryptography system, and so we will have to have new algorithms. AES will be fine, but RSA is going to go away. But it's not going to happen for about 10 years. And right now, the National Institute of Standards is developing the new post-quantum cryptography. There are something like 70 algorithms proposed, and they're now going through like a 5-year process of competing and deciding which one to take. The current leader is from Google, and it's called The New Hope. And it's doing lattice-based cryptography, and I haven't got the project up yet, but I'm hoping to add a project this semester where you use it. It is kind of strange. But anyway, that will survive the quantum transition, supposedly, but there's a process of testing going on right now. So no one really knows. Perhaps someone will find a flaw in that one, and it'll be one of the others. But soon there will be an official replacement for RSA. It's a very good question. Yeah.
So electrical cryptography, like,
It's also going to go away.
Yeah.
ECC and RSA and LGML are all going to go away. They all are based on the same type of hard problem, which is no longer going to be hard once you have a quantum computer. And even RSA with a longer key is no longer going to be hard. Even RSA with a 1,000,000-bit key is not going to be enough with quantum computers actually work. Now, of course, another possibility is quantum computers might never really work. There are some prototypes out there. The current quantum computers are not really useful for anything. They have not yet achieved quantum supremacy. They cannot do anything that a classical computer can't, but they're improving fast, and people expect them to keep improving. If they don't, then none of this matters, and we can keep using RSA forever, but people expect in 10 or 20 years, we will have to quit using it. So this actually means something. This is actually one of the huge problems in cryptography. You might have a system that is unbreakable today, but is that really good enough? What are you doing? If you're storing things like medical data, it's not okay if that is revealed in 10 years or 20 years or 50 years. And yet, how can you possibly have anything and promise your governing agencies and customers and board of directors, I know that no one will hack this in 50 years? That's really hard. So it's a problem. Basically, if you have data that you're going to protect for a long time, you're going to have to expect to keep re-encrypting it every couple of decades to keep up with improvements, I would think. That's why that's one of the several really hard issues. Anyway, I wanted to say a little bit about blockchain. That was my plan here. I have a Bitcoin slide someplace, which I'm strangely not finding. Just a moment. Oh, wrong class. That's why. All right. All right. Here. There we go. There we are. And this is the latest one is this one, 80118. All right, that'll do. I just want to say a little bit about cryptocurrency because it's, of course, a really big issue. And so I got 2 books here that helped me do this. And there we go. All right, Digital Gold here. This is the book written by a Bitcoin enthusiast saying Bitcoin is the greatest thing in the world, going to end war and save us all and everything. And this is the opposite, the 50-foot blockchain. This is a guy that absolutely hates Bitcoin, pointing out how it's all just garbage. And it's good to see both sides. The enthusiasts all think it's going to save the world. And basically, the way it works is people who are not financial professionals pretty much think Bitcoin is wonderful. It's going to replace the banks and all the governments and everything. And anybody who's actually an established financial professional has got no time for it at all. And I used to be, to some extent, a financial professional working in an escrow agency, and that's probably why I have total contempt for this. I mean, there's a reason why we have government regulations, the Security Exchange Commission, bank reserve requirements, bank financial reporting requirements, oversight, lawsuits, because people steal money right and left. And there's a whole bunch of government protecting you. And the whole point of Bitcoin is let's get the government out of our money. And anybody that's part of the established system says, you're out of your mind. That's the last thing you want to do is get the government out of your money. The government is the only thing stopping everybody from stealing your money. But the technocrats like Uber and such, they believe that you should disrupt everything. And we don't really need government or laws or cops or anything. We'll just put everything on the blockchain and make everything an app on your phone and everything will be wonderful. And then when people start killing people with the Uber cars, then they say, wait a minute, shouldn't you have had a license and insurance and vetting? And say, oh, gee, that's all that square stuff we were disrupting. But you kind of need all that. So anyway, we're living through this time where these 2 issues are colliding. So there's another little video that explains a blockchain. If you haven't seen it, this is a good thing to do. Let me bring it up. Probably there. This one is worth it. Since I have speakers, I can play this one.
When you vote, have you ever wondered whether your ballot is actually counted? If you meet someone online, how do you know they're who they say they are? When you buy coffee that's labeled fair trade, what makes you so certain of its origin? To be sure, really sure, about any of those questions, you need a system where records could be stored, facts could be verified by anyone, and security is guaranteed. That way, no one could cheat the system by editing records, because everyone using the system would be watching. Systems like this are on the horizon, and the software that powers them is called a blockchain. Blockchains store information across a network of personal computers, making them not just decentralized, but distributed. This means no central company or person owns the system, yet everyone can use it and help run it. This is important because it means it's difficult for any one person to take down the network or corrupt it. The people who run the system use their computer to hold bundles of records submitted by others, known as blocks, in a chronological chain. The blockchain uses a form of math called cryptography to ensure that records can't be counterfeited or changed by anyone else. You've probably heard of the blockchain's first killer app, a form of digital cash called Bitcoin that you can send to anyone, even a complete stranger. Bitcoin is different from credit cards, PayPal, or other ways to send money because there isn't a bank or financial middleman involved. Instead, people from all over the world help move the digital money by validating others' Bitcoin transactions with their personal computers, earning a small fee in the process. Bitcoin uses the blockchain by tracking records of ownership over this digital cash, so only one person can be the owner at a time and the cash can't be spent twice, like counterfeit money in the physical world can. But Bitcoin is just the beginning for blockchains. In the future, blockchains that manage and verify online data could enable us to launch companies that are entirely run by algorithms, making self-driving cars safer, help us protect our online identities, and even track the billions of devices on the Internet of Things. These innovations will change our lives forever, and it's all just beginning. To learn more about the urgent future of the blockchain.
Okay, so this I think is very useful. It does explain the essence of the blockchain, and also the political issue is very clear here because everything you heard was a lie. It is glossing over all the problems, and the problems are very large. And notice how completely contradictory it is. The first thing it says is you can tell who you're talking to in a chat room, even if they're lying. And by the end of it, the blockchain is protecting your private identity so people can't tell who you are. And at the end, and after that, the blockchain is driving your car. And I'd really like to know how that's working. But the point is, people think Gartner has a chart of this. There's this, when a new thing comes out, everybody says, oh, it's the answer to everything. There's this peak of inflated expectations for, this is it. This is the answer to everything. Well, look, we all live in a glorious utopia where this new technology solves every problem. And then there's disappointment. You say, oh, it's all full of problems and it doesn't work. It's totally worthless. And then finally you knock it off and say, okay, it's just another thing which has some value. It's not the answer to everything. It's not totally worthless. It has some value. And so in 5 years, every company is going to have a blockchain on their network because there are certain cases in which it is useful. But it's not going to solve all the world's problems and end war and everything. But it will be part of your network, and so it's good to understand. But all right, let me get back to my slides here. And so let's talk about how it works. So there's a live blockchain demo, and there's even a project where you can get points for doing this. So let me bring it up. If I go here, and here's 141. I just added these things down here in the extra credit section. This is the simple blockchain project. So let me just show you this one. A European blockchain developer made a nice online demonstration of it, which is very good to learn. So if you go here, he has a blockchain you can just see in your browser. And that's, of course, useful to understand it. So here's what a blockchain is. You can put data in here and say whatever you want. So I can say Sam has 10 coins. And when I do that, this thing turns red because this block has not been mined. So now you can add data here. Joe has 1 coin. Sally has 3 coins. So you put in data. And you add data to this thing as long as you want. And then there comes a time when you decide, I want to seal this, so it can be a permanent record and not changed, and then you mine it. And the way you mine it, you have to do some calculation, and what you're doing is changing this nonce number. You change this nonce number until you get a hash value, and the hash value has to start with a bunch of zeros. And for Bitcoin, the hash value is the SHA-256 of the SHA-256, which is a common hash function. This turned out to be a mistake, but that's where we are. So there's no predictable way to create a hash value. It's basically random. So the only thing you can do is do millions and millions of guesses at that notch until you happen to find one that starts with a certain number of zeros. Now, in this case, I only need 4 zeros, which is 4 bits for each one, so it's 16 bits of zero in this one. Just because it's a demo, the real Bitcoin blockchain, it's about 66 bits of zero. So it really takes hundreds of millions of calculations to find one that works. And this is what the Bitcoin miners are doing, just guessing a random number to add to it and doing thousands, trying to race to see who does this. Because whoever mines the block, they get a reward. They get to put that in the block. So it might be Sam mined it, he gets to give himself 10 coins. So now we're going to have Sally gives Sue 3 coins, and then Sam's going to mine this, and let's say Joe's going to mine this one. So Joe will put in here, Joe has 10 coins. You get the privilege of giving yourself some money if you mine the block. And so, but you have to win the race. The first person in the world that mines the block wins, and they get the coins. That's what miners are doing. They're racing to mine, and they're getting a reward every time they do it. So, and this chain, this block includes not only the contents of the block and the nonce, it includes the hash of the previous block. So if somebody tries to lie, like Sam decides he wants 20 coins, it breaks this block and it breaks that block. All later blocks are broken because it changed this hash and it changed that hash, which is included in this block, and that's why it's a blockchain. If you check the latest block and it adds up, then you know the whole chain is intact up to that point. So it's easy for anyone to verify that it has not been altered, and it's very hard for anybody to alter. Now you could still cheat. If you were really faster than all the other computers, you could actually go back like 3 blocks, change all the numbers, and recalculate them all so fast that you still win the race for like block number 4. And now the other people would be on what's called an orphan chain. Their stuff would not really happen. Your stuff would happen instead. Or you could do something simpler. You could spend the same coins twice in 2 blocks that are being mined and arrange to, that's double spend, which is a fundamental problem in the system. Anyway, the thing that prevents this is the race to do the mining, because the financial reward is adjusted so that the idea is if you have a really fast computer, you will earn more money by mining blocks honestly than you would by trying to cheat the system. And so there's a financial motivation for the fastest computers in the world to mine the blocks, and therefore anybody else that wants to cheat can't do it because they don't have the fastest computer. Now this is somewhat fragile because you could imagine an adversary, for example, who's not motivated by money, like maybe the NSA or Russian government or something. Maybe they have a super fast computer and they don't care about money and they're going to forge the blockchain anyway, just to mess it up. They could do that and you'd be hosed. But what's a much deeper problem is that there are hundreds of cryptocurrencies. There's Bitcoin, which is the first one and the most important one, and then there are hundreds of other ones, and the other ones are much smaller, less popular, and they have less miners, and the miners have less power. So if you're a Bitcoin miner and you're like, say, number 10 fastest one in the world, you won't make any money because you're not winning the race. The fast ones are making all the money. So what you do is you go to one of the other coins where the competition is less, and you're now the fastest. Now, if you're just the fastest, you could do all the mining and get rewards. But if you're really a lot faster, like 2 or 3 times faster than everybody else, to where you alone are more than 51% of all the computing power, then you can forge the blockchain. The whole security model is shot. So this security model, which is called proof of work, only works for one cryptocurrency on Earth, because the security comes from the fact that the fastest computer on Earth is doing the mining. How can any smaller thing have the fastest computer on Earth? It can't. There can only be one. So all the other ones are sitting ducks. And this has happened in the last 3 months. 6 of the small cryptocurrencies have been totally hacked by 51% attacks because they don't have enough people mining them to have the fastest computer on Earth in them. And so their security is an illusion. They just haven't been hacked because people haven't bothered to hack them. And there has been an attempt in the Ethereum community and other communities for the last 3 years to invent an alternate system called something like proof of stake. And so far, I haven't seen any version of it that works at all. Yeah.
And then to play off of the issues with proof of stake is, with like proof of stake, you have to stake your share in the in the cryptocurrency. And now as the prices of cryptocurrencies fall lower and lower, it only costs like $1,000 to be over 51% of the entire market of some of these smaller coins.
Yes, this is a huge issue. So, I mean, these things, these public blockchains are kind of insane. And the goal of them is to like disrupt the world economic system by cutting the government out of being able to print money and such, which is a very strange goal. So that the public blockchains are kind of a weird political stunt and kind of madness. And I don't really recommend getting involved. However, private blockchains controlled by a company are just another form of database, and those have some potential value. Anyway, so that's the live blockchain, and you can do this project and get some points to show that you played with that demo, and you see how the blockchain works. So here's how Bitcoin works. Actually, Bitcoin, a lot of people say, I wish I'd gotten in Bitcoin early, I'd be rich. And that is not what would happen. If you'd gotten in Bitcoin early, you would have lost all your money when Mt. Gox went down. That's what happened to everybody. There's tons of scams. When you get the government out of your money, you have this thing called the Wild West, where people are just stealing money from each other and shooting each other right and left. And average people are just hosed. So anyway, there's pyramid schemes and scams and a whole lot of schemes. The simplest scheme is enormously effective. I open a Bitcoin exchange and say, you can buy Bitcoin. Give me your money, I'll buy some Bitcoins. Great, give me your money. Now I'll not give you any Bitcoins and just leave and keep your money. Ha, ha, ha. A lot of them do that. That works just fine because people don't understand the technology. They don't understand that it's that easy. Then you go to the cops and you say, I lost my money. They say, well, okay, what jurisdiction was it in? They say, I don't know. I sent it to some guy named Flappy Doodle on the internet. I don't even know what country it's in. And the cops say, what did you do that for? And what do you expect me to do about it now? Why didn't you go to a bank where we'd have laws and government and rules, and then you could sue somebody and lock somebody in jail? But if you send your money to some random idiot on the internet, and then you come tell me to save you, I don't know what you think I'm going to do. You're the one that wanted government out of your money. Well, now you've got it. I hope you're happy. Anyway, so like I say, in 2015, I said to teach kids about Bitcoin, give them a piggy bank, 6 months later, smash it and steal the money, then laugh. Now your kids understand Bitcoin. Anyway, but Bitcoin was a mathematical curiosity when it was invented in 2008. It was invented by an anonymous person who never revealed his identity, called himself Satoshi Nakamoto, generally considered to be a British mathematician. But this person owns an incredible amount of money, hundreds of millions of dollars of Bitcoin, and has never cashed them in. That by itself should give you a little pause. How many financial organizations have a founder that won't even take their own money because they don't have any respect for the system? That's disturbing. Anyway, he invented the thing, and for like 2 or 3 years, it was of no value at all. It was just a mathematical curiosity because there were a certain amount of people that wanted to make internet money. There were a bunch of people trying to develop different forms of internet money, and he had this new technique that we thought would be better, and he and his buddies mined it and made some Bitcoins, but it wasn't trading for anything because you couldn't do anything with it. Nobody would accept it for money. The reason it became popular is because of Silk Road. Silk Road opened on the darknet behind Tor, and you could buy illegal things on Silk Road, like drugs and prostitution and murder for hire and anything else. He said, we're going to make a free economy without all that evil government in it, where you can just do anything, no matter how loathsome. And therefore, you have to pay with Bitcoin. Because at that time, it was generally believed that if you pay people with Bitcoin, they can't find you. Now, that is fantastically false. It is actually the worst possible way to commit crime because there's a public blockchain that everybody can look at. There's a permanent record that everybody has of who did what. The only thing is, if you're smart enough to keep making a new account number for every transaction, then it's hard to figure out who owns the account numbers. But many people aren't that smart, and you're leaving a permanent trail of everything you do in a public blockchain. But it was considered desirable to commit crime with Bitcoin because the law enforcement and banks and courts and everything did not understand it. So there was a period of time when you could get away with stuff because they hadn't figured it out. Like there was a period of time when Tor would hide you from the cops. That both of these things are now over. The FBI and the cops and the international law enforcement agencies have figured out how to pretty much de-anonymize Bitcoin. They figured out how to pretty much de-anonymize Tor. But it is relatively expensive in both cases. So if you commit small crimes, they won't catch you. But if you commit big enough crimes, they can hunt you down because it's not impossible. It's just a lot of work, and they have figured it out. But anyway, so Silk Road made Bitcoin go up to about $300. And then ransomware came out where people would infect you, encrypt your files, and you'd have to pay Bitcoins to get them back. So companies would stockpile Bitcoin so they had it in case of a ransomware attack, and that created a demand for it. And then economies came out like Argentina, where their local currency is so bad and the inflation is so bad that they're better off with Bitcoin. And this is the real point of Bitcoin, is money laundering. The whole point of Bitcoin is to do something that your government will not let you do legally. And in countries like Argentina, it's to hide your money somewhere where it's not subject to their inflation. And that's, by the way, this is not specific to Bitcoin. This is true of all new technology. There was once a thing called the Fisher-Price video camera. Before there were normal video cameras, there was a Fisher-Price video camera that recorded on an audio cassette tape a really low resolution black and white movie, like 200 by 300 pixels. And it was to buy it for like $100 at Toys R Us about 20 years ago. It was the first commercial video camera. And the first thing everyone did was make gay porn with it, which really bothered Mattel, who was making it, because they thought they were going to sell it to children who would make videos. But the fact is, there was a large group of people that wanted to do something that was kind of forbidden. And when you have a new technology, they all jump on it. I mean, who would use Bitcoin to buy things? Credit cards work, cash works. Why would a normal person use Bitcoin? There's no value in it. The only people that are going to use it are people who can't use the normal routines because what they're doing is illegal or scandalous or forbidden in some way. Those are always the early adopters, are people who cannot use the current system, usually because it's illegal. So the people that flood in here are trying to commit crime. And then came speculation. When Bitcoin started going up in 2017, people bought it just because it was going up. That's called a bubble. So, but there are many, many scams. Mt. Gox was the main Bitcoin exchange for years, and they lost all the money. The founder either stole it or didn't secure it and let somebody else steal it. And that was 7% of all the Bitcoins in the world stolen from that one exchange. There's a lot of articles written about it. By the way, the name of the exchange is from Magic the Gathering Online Exchange. He made the domain name to trade playing cards for a game. And then when he decided to open a Bitcoin market, he didn't even feel like he could afford to buy a new domain name. He just reused the old domain name, which is another of the many disturbing things that give you a clue that you are not dealing with real professionals with a professional product here. You're dealing with sort of lunatics. Many, many other people got hacked. Foreign exchanges, local exchanges, Bitstamp, all over the place. They get hacked over and over and over again, lose the money, just steal the money. Some of them even just steal the money and then leave a message. I took your money. You guys are all idiots, things like that. Many, many thefts. Large amounts of money got stolen. And then when the Secret Service started busting Silk Road, the Secret Service agents stole the Bitcoin. And then they went to prison because so many people didn't understand it, that the FBI agents, the Secret Service, were also corrupted. There was this money sitting there in a way that you could actually steal it and apparently get away with it because other people don't understand what it is. But of course, before long, they did figure out what it was, and those guys got busted. So here's the price history. Until about 2013, it was at zero. It was just being a small number of people were mining Bitcoin just to do a mathematical analysis of it, but nobody would use it publicly. Here's the 2014 peak up to $300. That was Silk Road, where you could start buying drugs and stuff with Bitcoin. That was some value. And then it sat around until 2017 when it went up to $20,000 for no reason at all. And I was teaching classes and giving talks at this time. And I said, why? What is it that you could do with a Bitcoin in December that you couldn't do with a Bitcoin in January? Why is it suddenly worth 20 times as much? And the answer is nothing. There's no reason at all for that. It's just a phenomenon where it gets popular enough. And so that's speculation. That's a bubble. And this and the last election made me feel like we're going through a paroxysm of human stupidity that hasn't been seen before. But in fact, this has been seen before. There have been a series of bubbles. And this closely maps one of the big ones in the 1600s called the tulip bubble. They'd never seen tulips in, I think, Holland or someplace. When they brought in tulips, people started buying the tulip bulbs. And within a year, people started bidding the equivalent of $1 million for a single tulip bulb at that time, because it's as much as a fashionable mansion, and then suddenly it collapsed. This tends to happen when some new exciting thing happens and everybody thinks they're going to get rich. They all jump in until they bid it way above where it is, and then they all sort of wake up and say, wait, what are we doing here? And it falls, and that's what happened shortly after the year changed. So anyway, one of the fundamental point of Bitcoin is it's supposed to be distributed so no one person can manipulate it. But because they chose the mathematical calculation SHA-256 of SHA-256, Bitcoin mining is entirely dependent on CPU speed and nothing else. And that means all that matters is getting the cheapest electricity. And the cheapest electricity is available in China because there's corruption. You can sort of bribe people and get free electricity there. So that means almost all Bitcoins are in fact mined in China by 10 people. And that means the Chinese government and this consortium of Chinese miners completely control Bitcoin. They have more than 51% of the mining. So if they aren't stealing the money, it's just because they don't feel like stealing the money. And the whole logic that you're safe because it's distributed is false. This is exactly what the whole point of Bitcoin was to prevent. You might as well just buy the yen because you're buying a Chinese product controlled by China. So what is the huge distribution being free from government control and everything? It's a lie. Anyway, then people got worried about the power consumption. This was a big deal at the end of last year. Bitcoin was growing so fast that it got up to using 0.1% of all the power in the world. And people said, oh my God, it's going to cause pollution and everything else. And I said, well, okay, so I made this graph, right? Here's Bitcoin mining. The prediction is it will use all the electricity in the world by like 2024. So I put this graph on Twitter because I thought this was a sarcastic way to point out to people, obviously, you can't predict from this. And people said, oh my God, I'm afraid I've got to like go hide in the basement and get a house. And I said, look, this is, when you see this, this means you don't extrapolate a straight line that far. So I said, let's try this one. Let's extrapolate out a little further. By 2090, it'll be the entire mass energy of the universe consumed by Bitcoin mining if you extrapolate the line out there. And people still didn't get it. I said, dude, right? Perhaps I've heard of something called sarcasm. You don't take that much data and extrapolate it that far unless you're an idiot. People did this in 1999. That's why they had the internet bubble. In 1997, there was no internet. In 1998, there was like $50 million. In 1999, it was $100 million. People drew a straight line and said, we're going to get rich, rich, rich. Invest in the internet, because there are brief periods of time when something is going up fast. It doesn't keep going up fast very long because it hits some kind of limit. And that's what happened shortly after this Bitcoin crashed. So anyway, that's blockchains. Blockchains, people are hiring blockchain developers, and there are quite a lot of blockchains out there you can set up and you can get jobs. All the big companies have blockchain projects. IBM is big. Microsoft is big in it. And so,
Amazon just really quick.
yeah, everyone's got them. So I mean, blockchain is going to be a kind of database. The point of a blockchain is it's a way to store a record that several people can keep an undeniable record of what they did. One example, one of my students I was teaching last summer had a blockchain startup, and he was working for McDonnell Douglas, I think, one of the main military contractors. And they have a blockchain application, which is supply chain management. They're building something like an airplane. And in order to have an airplane, they have to have like electronics from one country and metal from another country and some other product from another country. And all these suppliers are supposed to deliver stuff. But of course, when they deliver stuff, sometimes it's late, sometimes it's inferior quality. And so then they have an argument, and they all have contracts saying you must deliver this much and you pass this test. And then they say, oh, you lied about it. So they want to have a real record of exactly what was promised, exactly what was delivered. Now who owes me a penalty for this? That's supply chain management. And that's the kind of thing you can solve with a blockchain, where you have the point of a blockchain is it's a database where everybody can write to it, but nobody can change it. So it's different than, say, Dropbox. Dropbox, you make your files and you can write from all these locations, but anybody can change it. There's BitTorrent, where you can put up a movie and everybody can download it, but nobody can change it. Blockchains are a distributed database where everybody can write to it, and the blockchain will just get longer, but nobody can change the past. So it's good for a sort of legal record of what happened. If you're going to have some kind of financial arrangement between people who probably don't trust each other, like it goes across international boundaries and there really isn't a court system or a government across all there. So the blockchain is a solution in that case to keep records of what everybody did, what they promised, what they really delivered, so we can, you know, spare ourselves a whole lot of lawsuits and stuff. Hopefully everybody can see what really happened. So it does have some value. It's not going to replace databases, but it will be in addition to all the other servers. You'll have an email server and a domain controller, and you'll have some kind of cloud storage like Dropbox, and you'll have other things. You'll have SharePoint for people to collaborate on things, and you'll have a blockchain server in your company for the particular parts of your business that require dealing with other people you don't really trust. So it's useful to learn how to do it because it will be part of the IT world. Yeah.
And in practice, we'd be able to confirm the identity of those who are signing the blockchain?
Yes, in practice, these are private blockchains, so you would do something like do all the mining yourself. That's, or only let people in your club do the mining. The public one, where everybody can mine, is this kind of crazy thing, which is intended to disrupt the world's money, and that's not really exactly clear that that's benefiting anybody. The private blockchain, controlling your server, just like a private cloud. Most people want to have all their mobile workers be able to access things, so they want to use the cloud, but they want to have a private cloud so they know where the stuff is. They know where the servers are. And so it's the same thing here. Private blockchain is the reasonable answer for most actual business applications. A public blockchain where everybody can see it is kind of nuts. And it's kind of illegal to use it for anything because it violates all the privacy regulations. Like you couldn't put a normal bank balance in a public ledger like Bitcoin. It's illegal to take what you do in your bank account and publish it to the whole world. There are privacy laws. You can't do that. It's not appropriate for that kind of data. And almost no business data is supposed to be that public. So the public blockchains are of very little business value, but private limited blockchains do have a certain value. Anyway, that's what I wanted to show you here. And now we're up to 6:47, got a little bit of time in. I just wanted to start you with a little bit of the binary today. And next time we'll start doing the chapter. So you should start reading the book. There are quizzes you should take before class. You're not going to be considered late until after the ad period's over. So if you do take them later, it's all right. But I recommend taking the quiz before the class. That works better. I learned this a couple of years ago. Students take an online quiz, so they study the chapter before the lecture, and then they end up learning it better. The whole point of the class is just game design. I used to write games years ago. This is just a game to trick you into learning by making you go through the stuff a few times. You have to read the stuff and take a quiz, then you have to come to class, and then you have to do some homework practicing. It's just a way to trick you into going through it a few times so you'll learn it. Anyway, so next time we'll start the book with encryption, and we'll go into block ciphers and stream ciphers and all these things. But this time, I want to start you with the simple bit of math. There's only a little bit of math in this course. Like I say, we are not going to do any of the advanced math that develops cryptography. We're just going to learn how to use it. But you do need to know a little bit of binary. So if you don't know binary, I will encourage you to learn this much binary, a little bit of binary. So I made some binary games here, and I've got some Kahoots, so you can get some extra credit by doing them right today. So let's talk about nibbles. And one thing about the system here with these interactive quizzes is I get to see how well people are learning it, so I can decide how far to go. So if you all know binary, we'll do a few of these. If you aren't getting them right, we won't do very many of them. But I'm hoping to do a little bit of this every time. So with hopefully no great pain, you'll learn a little bit of binary. So here's in base 10, if I write down 147, the 1 is the number of hundreds, the 4 is the number of tens, and the 7 is the number of ones. And we're all used to this. I don't know about you, but I remember in like second grade how strange and baffling this was to me at first. It is a strange way to write numbers where the 1 has different meaning depending on where it is, but that's our system. That's base 10. You have the hundreds place and the tens place and the ones place. In binary, you only have 2 numbers, 0 and 1, instead of 10. So if you write 1, 1, that's 1 times 2 plus 1 instead of 1 times 10 plus 1. So you got a 1's place, a 2's place, and a 4's place. And the only thing you can put in there is 0 or 1. So you count to 7 like this. 1, 1, 1 is 7 because that's 4 plus 2 plus 1. And 1, 0, 1 is 5 because it's 4 plus nothing plus 1. And that's 3 bits, and if you take 4 bits, you have a nibble, which is half of a byte. And that's as far as we're going right now. So that number is what we would call 9. 1, 8, no 4s or 2s, and 1, 1, it's 9. It takes 4 bits to make a 9. And only 1 digit. So here's all the nibbles. There are only 16 of them. 1, 1, 1, 1 is 15. That's the largest possible 4-bit number. 8 plus 4 plus 2 plus 1. The smallest one is 0. There's a total of 16, and you should be able to figure them out. One handy trick is that 10, 10 is 10 because it's 8 plus 2. I've memorized that. That makes it very easy to turn binary nibbles into base 10 in my head. So let's see if you can do that. I've made a Kahoot with some of those to do. So let me bring up my Kahoots, which I guess I can just put here. Kahoots are online interactive quizzes, which serve the purpose of hopefully stopping people from falling asleep so much. And it's worth extra credit. If you get the most Kahoots right, you will get 3 extra points for each Kahoot where you are the top scorer. So I should have a binary 1 in my favorites. There we go. Binary 1, nibbles. There we go. All right. And there will be glorious Kahoot music. There we go. All right. There you go. So open a phone or a computer or something and go to kahoot.it and type in that number. And I'm going to make a document to store the winners in. Pardon me, there. All right. Okay. I'll give it a few more seconds. Yeah, people are still coming in. Good. This is not required, of course, but it tends to stop people from falling asleep. That's all it's for. All right, another 5 seconds, and we'll go ahead. Ah, here comes another. Okay. Anybody more coming? No screams of protest. Okay, off we go. So, what's 0011 in base 10? I wrote it like Python. 0b is binary. So 0011 in bits. All right, that's 3. It's 1 plus 2. Good. Everybody's getting that right. Good. All right. So what's this one? 1111. You get rated on accuracy and speed. All right, that's 15. 8 plus 4 plus 2 plus 1. All right, how about this one? Okay, that's 10. 10 is 10 because it's 8 plus 2. All right. How about 7 converted to base 2? Okay, good. 111. How about 6? All right, 110, 4 plus 2. How about 14? Okay, 110, by the way, notice the even numbers in base 10 are also even in base 2. They have to end in 0. Even and odd works the same in any base. What's that? What's that?
Is there a reason why
Oh no, they do that just to give shape cues. Yeah. Yeah, that's the game part of this thing. All right. All right, and what's that? 1001 in decimal. All right, that's 9. And the last one, 12 in binary.
So we picked the answer name for all of them.
Okay. All right, good. So let's see here's the winners. Okay, these guys will have to tell me something resembling a real name to actually get their points. Don's might be a real name.
I'm done.
That's what I thought. Okay, that you actually get your points. These other people are going to have to expose their identity to me to find out who they're like. WITB. Okay, and Cherry. So what's your name?
Eli.
Eli. Oh, Eli, and your just start your last name?
W.
Just Eli W. Good. Okay. Oop, Eli W. That'll do. Okay. How about Cherry? All right. If the Harry gives me more resembling a real name, they'll get their points. Otherwise, they may not. Anyway, I think it might be worth doing one more of these. Almost everybody was getting those right. So I think it's okay to continue to the next bit, which is here. So we'll do the first bit of bytes. So that's the, well, I don't want the game, I want the lesson. By the way, these are worth extra credit if you finish this other game here and turn and get 10 in a row right. But there's the lesson I want for this. Okay, so bytes. Those were nibbles. Here's bytes. Let me make it big. Okay. So we've been here 147 in base 10, and here's base 2, the same idea. So you have 1s, 2s, and 4s. And if you have 4 of them, you can get up to 15, from 0 to 15 with nibbles. That's 4 bits. You have 1s, 2s, 4s, and 8s. But we normally use bytes, so they have 8 of these. 1s, 2s, 4s, 8s, then 16s, 32, 64, and 128. So when you are new to binary, you do it the hard way, which is this way, which is pretty annoying, but it will get the answer if you're careful. So if you want to get this number, 1001, 1001, you have to add 128 and 16 and 8 and 1, which is kind of annoying and hard to do in your head, but it will get you to the right answer. The cool way to do it is with hexadecimal, which we'll get in later lessons, and then you can actually do it in your head. But this way is the simplest conceptual way, although a little bit difficult mechanically. So you should be able to convert binary to decimal for bytes, although if you do it this way, it'll be kind of slow and inaccurate. But anyway, that is, let's see if you can do some of those. That's, and then if in later lessons, we'll talk about how to do it faster. But at this point, I'll settle for doing it at all. So binary 2A is what I want. It should be someplace. Here it is, 2A. All right. All right. Should be playing music. Maybe it doesn't play music till later? Guess not. Okay. Thought it played music now. Maybe my sound is just broken. Nope. All right. I feel like the Martian. Where's the earth-shattering boom? Anyway. I'll give it another few seconds. I think we had a little more than 15 last time. I guess not. All right. 5 more seconds. Okay. So definitely missing the music. What's 2 in base 2? All right. Oh, there they are. There's a loose cable somewhere. Okay, that's it. 1, 0. All right, good. How about 20? Okay, that's it. It is 16 plus 4. All right. How about 254? They're getting weird with the music. Okay, if they're all ones, it's 255, so it's one less. The last number is 0. All right. How about 127? Okay, that's a harder one, but 128 is when you put a 1 on the left and all the rest is 0. This is the number just before that, 127. You could also add 64, 32, 16, 8, 4, 2, and 1, and you would get there, but it's hard to do that in your head. Anyway, all right, well, I think that's enough of that stuff for tonight. Oh, there's one more. Okay, the last one, 33. Okay, it seems like too many of them are red. Maybe I've got randomly or something. But they all been red, yeah. Yeah, there must be an option that's turned off on my machine. Well, anyway, I had a student actually figure, anyway. All right, well, this is why these things are extra credit, because there are various flaws in the system. Next time, I hope I can fix that. All right, WITB, that's, anyway, WITB was Eli. Okay, she's won twice, that's for 6. Caitlin, I don't know who that is. That's an actual human name. And I got Blood Mage. Will have to tell me who they are. All right. Anyway, so Blood Mage and Cherry are going to have to tell me who they are if they want to get points. Let's see if, nope, they're not sending me a chat message. Anyway, so I think that's enough for one night. You should, so let me just point out what you should be doing. What you should do is start reading this book and take the first quiz. You click this link and sign up on the Canvas. The quiz is multiple choice there. You get 2 chances to take it if you want. It's just to encourage you to study the book. And then start doing the homework. You can do extra credit homework down here. If you want to do exactly what we were doing here, you could start doing these blockchain things way down here. But if you want to stick to the required projects, we'll begin doing things like Caesar cipher and such, which we'll talk more about next time. You can also do these binary games. They're worth points. And I'll talk about the obfuscation and stuff next time. We're going to start the way every cryptography class starts is by doing the old historical ciphers, which are no longer secure, but that's how it started. And the modern ones are variations on them. So next time we'll do the old stuff like the Caesar cipher and the Big Mary cipher and all that, and the one-time head. And then we'll move into the modern stuff like AES and RSA and SHA-1. So any questions about anything? Does anybody need an ad code?
Is the extra credit arbitrary which class
You can, is the extra credit what? You can choose any of
arbitrary?
them. You choose any of them to do their points like any other. So for example, if you were a super cryptocurrency enthusiast and you don't really care about normal cryptography, you could do all these cryptocurrency extras and not do the others and it would be fine. Points are points. It's like choose your own adventure. But I recommend doing this. In my opinion, the most important thing is to learn the standard cryptography. That's what everybody's really using. But some people are like John McAfee, super convinced that Bitcoin is more important than everything else in the world. And you can do that if you like. But I think you're going to discover that Bitcoin is not that important. And the same old stuff that everybody's really using to secure data is what's really important. Yeah. Anyway. Okay. Well, I'm going to go up to 214 to see if people want to work up there. But anyway, I'll be around. If anyone needs an ad code, I can bring them up here.
Just check the dynamic.
All right, yeah, let me just stop the share and I can bring up a list. All right, let's stop this and I